I think that should be fine. All right. So what you see here is a acute angle, right? Acute angle that is plotted in a standard position, right? By standard position, I mean the initial side. Zoom in a little bit more. The initial side is pointing to the positive direction of x, right? And the terminal side is located somewhere in the first quadrant. And the reason why I want to have the first quadrant is, the angle want to have an acute angle, right? So let's say we have a point P on this terminal side, and I'm sure you can see they label x and a y as the two perpendicular sides of this right triangle, right? I don't know if you can just make sure that you always focus on the right triangle here. That's what you guys like to do. Okay, there we go. All right, so I'm sure you can see that y, they label the x as the adjacent side of the angle theta, right? The y is the opposite side, because that's basically where the P is located. So if you're trying to recall the right triangle definition, or all 6 trig functions, right, regarding an angle theta, say sine theta, which you obviously remember, right, is opposite over hypotenuse, right? But do you see that now in terms of x, y, r in this right triangle, right? You just have to replace the O with the y, right? And hypotenuse, replaced by, the r. That's why I don't want you to remember sine theta, right? And it's defined as the ratio of y to r in this right triangle as if that it's completely new. Try the cosine theta, adjacent over hypotenuse, right? So adjacent is x, hypotenuse r, right? I guess that I don't have to do any more, right? So now you might say, what is r? We can probably see from the figure here. R is the distance between the point P and the origin. Right? But you don't know how much r it is unless you know the x and y coordinates of P. And I'm sure you see that. To find out r, given the x and y, it's as simple as just calculating r using the Pythagorean theorem. Okay? Yes, Rebecca? Good question. Why am I going with x, y, and r instead of opposite, adjacent, hypotenuse, right? Are you trying to, is that what? So the reason, as you will see probably in a few minutes, right now, you don't see any point of doing it since it's a right triangle, right? We know everything about the SOHCAHTOA stuff. But what if the P or the terminal side is not in the first quadrant? Then the angle is greater than 90. That means you're not able to find a right triangle anymore. But we still want to define all 6 functions. So you're not able to use the opposite, adjacent, hypotenuse anymore because they're not even there, right? So now, since Rebecca mentioned, there's some change of notation and the reason behind it, right? So now I think it's a good time to let you know what you should do about these definitions, right? So first of all, when it comes to memorizing it, can you guys make sure that always thinking about the right triangle and you try to write down these definitions as if that y is the opposite, x is adjacent, or it's hypotenuse. Can you guys do that? Imagine that you have a right triangle. So now guess what? Later on, when the angle is greater than 90, when the P is anywhere else, you stick to the same exact expressions. The same exact definitions. Whenever you're going to have to do with sine of theta, where theta could be 300 degrees, and it's still going to be y over r. But can anyone tell me in which quadrant is 300 degree? 1, 2, 3, 4. Where's the 300 degree? Okay, it's the fourth quadrant, right? Somewhere right beneath the first quadrant, right? Now, what about the signs of x and y if there's a point located in the fourth quadrant? Say, do we have a positive or negative x? In the fourth quadrant. Positive x. What about y? Negative y, right? Guess what? Here, I'm going to plug in exactly what the y is supposed to be for a point in the fourth quadrant. And it'll be negative, right? And you get a negative sign value. That's the weird part, but we stick to the rule. This is how we define the sign, as if that the angle is always in the first quadrant. When the angle goes beyond the first quadrant, you stick to the plan. But the price we pay is getting, negative values for sine, cosine, tangent, cotangent, cosecant, stuff like that, right? So it won't make too much sense because I'm just telling you this is how we define things, right? And unfortunately, we have to go with the more intuitive way, which is the right triangle, and we now extend it to any angle, right? That could be negative, positive, even going beyond, 360 degrees, right? Now, so I see that some of you are taking notes, right? Which is good. Or at least do me a favor, take a picture. Well, before you do that, let me get rid of those marks. Because I do want you to have them, right? These definitions when it comes to X, Y, Z, right at your fingertips. Because later on, when we do some problems, I want you to look them up, right? And it's not bad at all to look these up because, I don't have to, memorize them. So like you thought I have to, right? Anyway, so now make sure that everyone have at least, these 6 functions defined in terms of X, Y, Z, either in your notebook or as a picture in your phone, because you need that for, the next, few questions, right? Now here's what I want to show you, and it's in the textbook. And guys, don't forget, when you get my notes or even my recording, it's not going to include the textbook, right? And also the PowerPoint from the publisher, because I'm not supposed to show you that in the recording. So you guys need to get those things on your own, which is actually in Pearson, right? Pearson 1.3. But what I'm about to show you is that example, talking about how to use those weird definitions in terms of XYZ, not XYZ, XYR, for points and angles which are not in the first quadrant anymore, right? Just to have an idea that how that should work out, at least in a relatively straightforward manner, right? So 5.3. All right, let's take a look at example number 1. Again, this is not going to be part of the recording, so make sure that you either get it from your textbook or, let's say, the PowerPoints you can find in Pearson. So now we have a point, -3, -5, right? So you can see, obviously, it's in the third quadrant. Oh. So sorry. They fixed the computer and I forgot about what I did before they fixing it. I should be showing you guys in the web browser so I can write. There we go. Hopefully it works now. Okay, so point P is in the third quadrant, right? As you have those 6 definitions of the trig functions. Let's try sine theta, right? So well, you don't have to memorize at this point, but later on you know that it's y over r, right? I don't care about hypotenuse, adjacent, opposite, because you don't see them anymore. There's not even a right triangle. So what is the y? Y is -5, right? So they put -5 here over the r. Well, how do you find the r? Always the same way, right? Take the square root of sum of the squares of x and y, and that's why they figure it out in the first place, because you're going to need x, y, r anyway. So unfortunately, you have to do some, rationalizing of the denominator, right? But you know that it's not wrong to leave the answer like that, but it's probably, better if you could, change that into, a slightly nicer form. All right, so now let's say, how about we try another, but let's make it a bit more complicated, all right, when it comes to memorizing it. So let's think about y secant is r over y, and try not to spoil yourself, right? So you want to look it up, I know. What is the function that you know much better than the secant? It's actually closely related to the secant. Secant and what else that comes together? It's a cosine, right? Well, turns out that it's the sine in a secant. Well, remember, Brian's way. Oh, sorry, Ryan. My bad. Ryan's way is like, tangent, cotangent both have the t, right? That's why they come together. And somehow cosecant and sine, they're so different from each other, right? So they come together, but as a reciprocal, right? Cosecant. Did I say secant? Oh, sorry, my bad. That's why it's confusing, right? Anyway, secant, cosecant. All right, cosecant and the sine come together, right? So it's the reciprocal. So now you see that if you try to picture a right triangle in the first quadrant, right? That's the angle theta. The opposite is the vertical coordinate. That has to be y, right? The hypotenuse r. So the sine of it will be y over r, and that's why cosecant, which is the reciprocal of a sine, has to be y over r over y, right? But I hope that it won't take you too long to figure that out. But later on, doesn't matter what you get for y, right, or even x, but you know that r has to be positive. So you're gonna stick to the plan, do y r over y, and now that's all you have to do. So do you see that it's completely pointless to find those values for the trig functions, right? As long as you can first write down all those definitions. If you have maybe a little cheat sheet, you can actually do that in a homework, right? But like I said, if you can never memorize them by thinking about the right triangle, right? But once you have those definitions written down, plug in a number for x, y, right, using the r, so that shouldn't be a big deal. But there's something you have to be very careful. So that will be either positive or negative signs, right? So you do want to respect the signs from the x and y. Not to mention you're not required to rationalize the denominator, but if you ever decide to do it, make sure you do it right. All right, so now let's go ahead and try a few problems based on the way we define those trig functions in terms of x, y, z, x, y, r. So hopefully that things are going to start making more sense. All right, so I'm going to switch back to my laptop. All right, so let's go ahead and try. I'll work this out for you, but feel free to follow along, or maybe just wait until the end and take pictures. All right, so we have a point P located at 1, comma, -3. Which quadrant is the P in? It has a positive x, right? A negative y. Quadrant 4, right? So now let's go ahead and draw quadrant, and I'll place terminal side somewhere here, right? And that's P. It's not drawn to scale, so don't be too crazy about, whether it should be closer to the x or y axis. 1, comma, -3. Okay. So now we have all. Oh, you know what? Let's first get the r, since you're gonna need it anyway, right? So it's the square root of x squared plus y squared. Right, so it'll be square root of 1 squared plus -3 squared. Okay, what is that? Radical 10. Okay, so now we have the r, right? X1 negative y, y is -3. So now let's go ahead and write down all 6 functions. The one that comes with the sign will be cosecant, right? And this is secant, and this is cotangent. So now what you could do is, like I said, hey, go ahead and draw a right triangle in the first quadrant, right? So label the opposite of an angle as the y, right? Adjacent is x, and the hypotenuse is r. So SOHCAHTOA, right? That tells you sine has to be y over r, right? Opposite of hypotenuse. Cosine is adjacent of hypotenuse, so x over r, right? Tangent is opposite of adjacent, so y over x, right? And then you go ahead and flip everything to get r over y, right? R over x, and x over y, okay? So now we just go ahead and plug it in, right? So y is -3, or is radical 10, right? So if you want, let me show that at least that what I'm going to show you are better in appearance. So if you rationalize the denominator, I guess that you're going to get 3 radical 10 over 10, right? And it's negative. All right, so we'll do the same thing for the cosine, right? But grabbing the value of x is 1 divided by r, so you get radical 10, right? So rationalizing it. I'm not saying that you have to, but if you could do that real quick, then I will say why not. All right, so y over x gets you the tangent. So y is -3, x is 1, so you get -3. Okay, and let me go to the right a little bit. Now for cosecant, I swapped the numerator and denominator, but I think that I would be better off to do that over here, right? That would be a lot easier. So you can get negative radical 10 over 3, right? So now when it comes to the secant, I need to flip, this guy, right? Instead of a radical 10 over 10, because that's, a little bit harder. I get radical 10. Now, well, this is going to be -1/3, okay? So let me pause, and you let me know if there's still anything that bothers you. Nothing hard, right? To find out r given x and y, make sure you take the square root. Take that as a quick way to remind you how to write down these definitions for all 6 functions, right? Imagine that if it were in a first quadrant, that's what it looks like, right? SOHCAHTOA stuff. But now the reality is you're not in the first quadrant. So you're going to stick to the plan that x and y still go into the right places. We have to respect their plus or minus signs. That's all. Okay. All right. Any questions? Okay. Now let's try this problem together. So it might seem, odd since you're looking at those special angles, right? It's kind of hard to imagine, those points. But then if you're really thinking about that for one more second, it's easier, way much easier, right? Than those random points which are not on, those special, like, edges, right, of quadrants. All right, so those are quadrantal angles. All right, so let me go ahead and draw out the quadrants. And let's go ahead and label what those points are. Right. Now, how about we call the point that's associated with the angle in letter A, like a point A, right, capital A. So where do you think the point A should be located? On the right side, right, somewhere on the x-axis, right? Now, how far do you think that the point should be away from the origin? Like, what kind of distance of r would you take? Or would it matter? So let's try taking the distance to be, I don't know, like 3, just random distance. Because they didn't say anything about why, the r should be calculated, right? Well, now you know that it depends on exactly where the point is. You get its xy coordinates, and you're gonna get, the distance are figured out based on the x and y, right? So now, if I pick 3 units away from the origin, and that's where I'm gonna plot the point A, can you guys tell me what will be the x and y coordinates of a point A, given that it's 3 units away from the origin? It will be positive 3 for x and 0 for the y, right? Now, let's try that for, the point B. I'm sure you can see that now it has to be on, the y-axis, right? I'm going to label that as, point B. So now, you guys make a choice, how many units you think that B should be away from the origin, and then tell me what will be the xy coordinates. How about take the distance to be 100? I hope you're thinking, why would we bother with the distance? What would be the easiest distance you want to pick? 1, right? I guess that either in the future we're going to deal with a unit circle, right? Or if the distance doesn't seem to matter, right? Because all you want to know, like, how far it is, because you're going to get the same exact x or y as the distance. So why would you make your life so hard? So if it's 1 unit away from the origin, it's on the y-axis in a positive portion, you have a 0 for x and a 1 for y, right? So now if we can take the same convention for the point C and the point D, right? So we're going to pick the same distance, right? It's always 1 unit away from the origin, right? So now you guys tell me, what will be the coordinates of the C? How much for the x? -1. Y is going to be 0, right? So what about D? 0 for x, -1 for y. There you go, right? So what do they want? Okay, they want cosine and a cosecant. Again, don't spoil yourself. Let me give you 10, 20 seconds to think. Don't look it up. What's the definition of cosine of, let's say, theta associated with a point? Let's try maybe make it maybe C, right? And I'm gonna, that you can work out, every single combination, right? So both cosine and sine for cosine and cosecant for all 4 points. But all I cared is, we're gonna try this one, and we're gonna try cosecant for the angle associated with the point D. Okay. So how should we define the cosine in general in terms of x, y, and r? X over r, right? You guys picture the right triangle in your head. The adjacent is x, right? X over r. Now, what is x for the point C? x is -1, right? Over, or is it 1 or -1? Or is the distance, and it has to be always positive. And we pick that to be 1 unit, right? So you get -1, right? And by the way, what is the angle associated with the point C? 180 degree, right? Or pi radians. So that provides you a way to memorize. Of course, it's going to take maybe a minute, right, to recall on a test. But cosine 180 is -1. But later on, you're probably going to memorize as is. But this is a way for you to figure it out. Okay. All right. So now, again, you guys tell me, how do you define cosecant in terms of x, y, and r? R over y. So what was the reason behind it? You just memorize it. Flip, right? Okay, good. Cosecant is the reciprocal of sine, right? Sine is opposite of hypotenuse. Opposite in the first quadrant is y, right? Hypotenuse r, so it's the other way around, r over y. So point D, we have, let's say, still 1 for the r, right? What is y? -1, so you get -1 again. Okay. Now, you guys try, one more. So let's take, oh, you know what? Let's do, yeah, that's tangent, right? Associated with point B. Go ahead, figure it out. How much is the tangent function of the angle associated with point B? Well, that's actually, one of the sine, cosine, tangent thing, right? So Soka told us, so you guys don't even need to. Say it again. How do you get 1? Okay, it's y over x, right? You guys agree, right? Okay, so now the question is, the y is, no, tangent doesn't have r in it. Oh, okay. So then it's not 1, right? So y is 1, but x is 0, right? What is that? Undefined. So now, unfortunately, you have functions like tangent, cotangent, secant, cosecant. They could be undefined if you go beyond the right triangle. Okay, when the angle is greater than 90, and it's potentially undefined. But sine and cosine are always defined. And the reason is actually pretty simple. Let me, I'll come back to this, if I haven't taken a picture. But let me show you why sometimes the functions other than sine and cosine could be ill-defined. Now, why don't you guys take a close look at the definition of a tangent, cotangent, cosecant, and secant. And imagine that those x and y's are a point, a random point, anywhere in a two-dimensional plane. You have y, x, right? Those coordinates going to the denominator. Do they make you worry? If the denominator might be 0, right? Now, if the x is 0, where do you think the point has to be? A point with a 0x coordinate. It should be somewhere along the y-axis, right? Now, let's say if you get a y to be 0, it'll be somewhere along the x-axis, right? So now, later on, you will see that sometimes angle is like 0 degree, like the one we drew over there. Let me see here. like the angle associated with letter A, right? So you see that the angle is 0 degree, and a point is on the x-axis, so it has a y to be 0, right? Do you see that among all those 6 functions, whichever function that has a y on the denominator must be ill-defined, right? But you don't have to memorize it. I'm not going to test you like you have to tell me in a second, whether this guy's ill-defined or not. You go ahead and compute whatever you're supposed to, right, using those definitions. But if you're lucky to find a trig function that's ill-defined, it's what it is, okay? And that's why sometimes you want to type in things in the calculator, and later on you'll see that there's a math error. You can try, let's say the angle associated with letter B is 90 degrees, right? If anyone has a scientific calculator right now and typing tangent 90 degrees, you're going to get a math error because it's ill-defined. Anyway, so I hope that you don't get too crazy about those quadrantal angles and some of the trig functions I will define. It's what it is. You still go by the same definition as we have before, right? If it's ill-defined, go with it. All right. Now, again, before I move on, because there's still something else that hopefully that later on you're going to memorize together with these definitions. But are there any questions about using x, y, r to find out the value of all 6 functions, even including that the angles are special angles like quadrantal angles? Yes, Rebecca. Exactly. So try cosine associated with angle A. Think about that. Cosine has to be x over r, right? Now, when I picked A to be 3 units away from the origin, so x is going to be 3, right? And how much is r? R is 3 as well, right? So you're going to get 1 for cosine 0 degree. But if you want to pick 2 units, right, 5 units, even 10 units for the distance from origin to the point A, you're going to get 1 for the cosine 0 degree no matter what, right? Because somehow you're going to get the same exact distance as the x coordinate, right? So that's why the distance doesn't matter. If you get to pick some easy numbers. But you're right. So later on, any distance you feel like picking, as long as positive, non-zero, you're fine. All right. So now let's back to the textbook again. And there's something. Oh, sure. Go ahead. I need to get rid of these things. All right. So now you probably realize that once we are getting angles greater than 90 degrees, sine, cosine, right, or anything that derives from them could be negative sometimes. So it turns out that it's very helpful for us to tell right away, just given which quadrant an angle in, so that we can expect some of the trig functions are negative. So this diagram, which summarizes all the possibilities for either positive values or negative values of all 6 functions, depends on which quadrant the angle is located. And again, you need to memorize that. Otherwise, you might end up going through the definition over and over again in the test. You could do that, but it's just going to be very time consuming. So let me explain real quick, because it's not really that bad to understand it. Maybe find out your way to memorize them. Now, in the first quadrant, they say all 6 functions are positive. Well, that's of course the case, right? In the first quadrant, you're basically looking at the right angle trig, right? Have you ever recalled any functions being negative in a right triangle? No way, right? Because they are ratios of, the size of a right triangle. Now, the second quadrant, when the angle is greater than 90 but less than 180, they say that sine function and cosecant function are positive. Now, first, does it make sense that when the sine function is positive, the corresponding cosecant function must be also positive? Because the sine and cosecant come together as a reciprocal, right? If one fraction is positive, the reciprocal has to be positive as well. So you don't have to memorize that in the second quadrant, cosecant must be positive. But you do have to remember that sine is positive in the second quadrant. How do you do that? Wait until we go through all quadrants, right? So sine is positive in the second quadrant. When we go to the third quadrant, tangent and cotangent are positive. And oh, by the way, if I didn't mention any functions, it means they are negative. So sine and cosecant are positive in the second quadrant, but all remaining four functions are negative. In the third quadrant, only the tangent and cotangent are positive. Does it make sense? If tangent is positive, cotangent has to be positive as well. They're reciprocal of each other, right? The last one, cosine and a secant have to be both positive. The remaining four are negative. So now here's the fun part. There is a way to memorize it, but many teacher or a different teacher might say it differently. Even a textbook sometimes, maybe just a different edition or publisher, they have a way for you guys to memorize. Oh yeah, Rebecca, go ahead. Go ahead. How come cosine what? Okay, let's take a look. All right, so here's a good question. So Rebecca says that, is there a way for us to see why the cosine and the secant is positive in the fourth quadrant? And let me refer you guys to, my bad, how we define the cosine and the secant. Do you see that? Cosine and secant depends on the x, right? Now, notice that all has to be positive. So do you see that if the x is positive, then cosine and the secant must be positive, right? But in the fourth quadrant, somewhere right beneath the first quadrant, x has to be positive, right? And that's why cosine and the secant, when the angle's in the fourth quadrant, the x is actually positive down there. They have to be positive. So now what about sine function? Why is the sine function negative in the fourth quadrant? Because remember that sine function is positive in the first quadrant, in the second quadrant, right? So in the fourth quadrant, sine has to be negative. Because somewhere down there, the y is negative. And we're using a y to define a sine function. But that's way much time consuming, right? So I don't want you to keep thinking about x, y, and r. Use that chart. Right? All positive in the first quadrant, sine and cosecant are positive in the second quadrant, and only tangent and cotangent are positive in the third quadrant, and cosine and secant are positive in the fourth quadrant. That's the funny way that the book tells us, so you can remember it. So a smart trick class. So A stands for all positive in the first quadrant, right? S stands for smart, but also sine, which is positive in the second quadrant, right? T stands for the tangent. Tangent is going to be positive in the third quadrant, and C stands for cosine, right? So I mean that's the way the book put it. I know two more ways. I don't mind to share with you guys. Whatever you like, or you can even come up with your own way, right? So the way I like it better, say all sines teacher crazy. So because I I was a science teacher, well I'm still a science teacher, but yeah. So again, S stands for the sine, and remember that cosecant that comes with the sine, right? So they have the same positive and negative signs, right? And T stands for tangent, right? C stand for, the cosine. So that's one version that I happen to know back then. And here's the second version. See if you like it better. All students take calculus. Not necessarily true, but it's a good expectation. All right. Again, you figure it out however you want to do it, right? But you have to remember, right? Which quadrant you think that those angles are in, and based on the angle and in a quadrant, you find out what those positive and negative signs are, right? Now, let's try a question to quickly check if you can now figure this out without going through those definitions, right? And pick a way to remember. All science teacher crazy, all students take calculus, or a smart trick class, right? I'm going to switch back to the laptop, and I'll give you maybe no more than 1 minute to figure it out. All right. So all you have to tell me is in which quadrant you think that the angle theta lies. If sine is less than 0, cosine is also less than 0. Keep the answer to yourself. All right, how about we do like a quick poll? Raise your hand. Tell me which quadrant it is. All right. Ready? Raise your hand. Let me know if it's 1, 2, 3, or 4. Okay. Great. Yeah. See that it's pretty much everyone, right? Pick the third quadrant, right? Does it make sense? Yeah. There you go. You just have to eliminate, right? So it's not going to be the first quadrant, right? It's not going to be the second quadrant, right? It's going to be either 3 or 4, but you know that the fourth quadrant cosine has to be positive, right? All science teacher crazy, right? The fourth quadrant cosine is positive. That leaves you no choice but to go with number 3, right? Yeah, there we go.